Hello, my name is Jonah Cowell. I wanted to thank you for joining me today for the session where I'll be going over some of our key results in this session today. What do 1,000 people say about open source observability? My name is Jonah Cowell. I'm the CTO here at Logz.io, and hopefully you'll find this informative and interesting for those of you using open source technologies to gain better insight into your infrastructure and applications. Little background on myself, coming from a practitioner background, I did that for over 15 years running infrastructure, operations, performance engineering, and security. I've done a lot of different things in my roles as a practitioner and a manager and a leader. And then I actually joined Gartner as a research vice president and covered the industry from an analyst perspective, giving thousands of companies advice on what types of tools, strategies, methodologies they should be using when it comes to their monitoring and observability. And then after that, I completed the cycle over on the vendor side, and I've worked for a couple of other startups in the industry focused on monitoring and observability. And I've seen a lot of interesting things in my time in the industry. So I wanted to cover off what I'm seeing today, where I believe the industry is going, and what Logz.io is doing to meet the needs of this industry as well. A little bit about us. We are headquartered in Tel Aviv, Israel. We have over 230 employees and over 800 paying customers today. We've raised a pretty substantial amount of money, and we're building a thriving business. Our second biggest office is in Boston, and we have other locations around the world. Some of our customers highlighted here on the bottom of the slide that we work closely with. You'll notice most of them are technology firms. Many of them host on AWS, and all of them are really cloud-based companies, cloud-native companies today. So we continue seeing this trend and believe it's an important path for the future. So we did a really interesting survey. The results were published right at the beginning of November. You can find more information about the survey from various sources. It's called DevOps Pulse. And it's something that we've been doing yearly for a few years now. And with over 1,000 people submitting results this year, it was the biggest ever that we've done. And this is completely open. I was tweeting about it extensively. Getting people to submit, getting people to participate. This is a real open survey. There's nothing closed about it. And you can see some of the information that we're showing here in the slide about the average size of the teams for those responding and what regions they're in. So it's pretty diverse in terms of small teams, large teams, and obviously it's skewed towards North America, but still a heavy response from APAC and from Europe, of course. Many of these respondents are customers because of the people who read our social media, for example, but there's lots of non-customers in here. You'll see some of the results, and I'll use it throughout the presentation. So as I dive in here, why observability? Why is observability important today? Most of us are building cloud-native technologies, and what this means is that we're moving towards microservices, or we're building on microservices. This is something that Uber and Netflix and many of the tech companies we all look up to started doing quite some time ago. And as things evolved, we soon realized that we had to run infrastructure in a different way. And you can see here over on the right-hand side are some Google Trends graphs going back for the last few years. And we used to see a huge amount of demand and interest in big data technologies like Hadoop. These have subsided because of all the wonderful services that cloud providers like Amazon have been building, making it easier to build big data systems and run those. But one of the things that we're all challenged with is how to run these microservices at scale. So Kubernetes is the de facto standard for running microservices today. And you can see how popular it is with that big trend line. The other interesting trend that we've seen take off is serverless, which you can see at the bottom here. It's slowly building. Obviously nowhere near the demand that we see for Kubernetes, but serverless technologies provide a lot of advantages and also a lot of challenges that are different. So when we talk about cloud native and we talk about Kubernetes, we can't help but talk about all the open source around these technologies. So the Cloud Native Computing Foundation is not a particularly old software foundation, but it was created around Kubernetes. Kubernetes was donated by Google to the CNCF. It's part of the Linux Foundation. And all these amazing technologies around Kubernetes have been part of the software foundation. Whether you're talking about Envoy or FluentD or Jaeger or Prometheus, these are all projects within the CNCF purview. The other major software foundation that really started out with obviously the Apache web server, but also expanded quickly around Hadoop and Spark and Kafka, is the Apache Software Foundation. And these two sets of projects are something that developers have really latched onto because they're accessible to all, they're driven by a vibrant community, they're very flexible, they're well accepted. So if people feel like they're future-proof, if I build something today that uses Kafka, chances are I can find lots of other people that know how to operate Kafka, that know how to deal with the intricacies of building technology around it. So it really provides a future-proof and an assurance that there's going to be a community around these technologies. So as we kind of dig into the survey a bit more, we asked, this is actually comes from 451 Research, who is a well-respected analyst firm, and they do a lot of polling and surveying of the general public. And they found in one of their recent surveys that monitoring is one of the main use cases for open source. You can see application development. Obviously, those of us that are building on languages, most likely they're open source based, but monitoring is up there on the list. So lots of folks want to do their monitoring and observability with open source based on this data and what I hear regularly from users out there. So when we talk about observability, a quick definition of what it is. It's really a way for us to take monitoring to the next level. And what this means is that we're trying to collect various types of signals coming from our applications and our infrastructure. So these are usually signals that are emitted from the applications themselves, from the infrastructure as well. And they take the form of three different distinct data types. The first are metrics. You can think of these as time series data. And this is used to detect a problem. My CPU is going up. My memory consumption is going up. These are all metrics. The next primitive is logs. So once we have an issue, like we're having a spike in response time, so it's getting worse, what's the cause of that? Is there some error message that's showing up that's really contributing to this problem? This is often what logs are used for. They're used to really diagnose problems, to understand what a system is doing. In highly complex environments or microservices architectures, tracing is a way for us to look at the end-to-end transaction path and understand where the problem is occurring. What team or what component can I correct or fix in order to improve the issue that I'm seeing? And so that's really what what these three signals are used for and why they make up the data around observability. So I'm going to talk a little bit about these three types of data and how open source tools meet the needs of these types of data. These are all completely open projects that many of you are using or are easily accessible. The first one is for time series for metric data. Grafana, really popular front end for analyzing and measuring time series. So this allows you to do dashboarding and alerting. Many of you are collecting data from your infrastructure, from your applications. That typically comes from Prometheus, which is used to collect this information. It's a very modular piece of technology. You can see in the diagram here, there's a few distinct components, and it scrapes or collects this data from various systems. Now, the thing with Prometheus is it's not amazing at storing data for long amounts of time. So many people will put something like Thanos or Cortex, these are other open source projects, behind it to analyze data for longer periods of time. So if I wanted to look at how my service was doing over the last 18 months, I may add something like Thanos behind it, which is another CNCF project. And then, of course, you need to have alerting. So Prometheus built a standalone component called Alert Manager that specifically deals with alerting. And that's really how they solve that problem. So moving on to the next data set, now that we've discussed some of the popular time series metrics projects out there, I did want to cover off a little bit about some of the popular logging products out there. And almost everyone out there that's been doing logging or trying to centralize log data knows about ELK. And ELK stands for Elasticsearch, Logstash, and Kibana. Now, Elasticsearch is still incredibly popular. It's a great technology. AWS has an Elasticsearch service that lots of people use. Logstash, however, although it's a good technology, there's been a lot of advancements in this area. So you'll see on the slide that I've included things like FluentD or FluentBit, which is very popular for doing this type of thing. And many people use other data collection methods. So if you're running Kubernetes, most likely you're using FluentBit or FluentD, which has a much more native integration to get logs out of the systems. And then finally, Kibana is the front end that's used to analyze the logs. It's also really popular. And these open source projects are great technologies, but the challenge is logs get really big and really complicated. And running these at scale and storing them can be a big problem. So the diagram that's down here on the bottom of the slide actually shows us how you scale out Elasticsearch. And unfortunately, it requires that you also run Kafka so that you can distribute the load that's going into these systems, both on ingestion and on querying. So it gets really complicated. Not only do you have to run massive clusters of Elasticsearch itself, but you also have to scale out these other components, Logstash components, Kafka components. And it can be a real challenge to do this. One of the things that we do at Logz.io is we really create a turnkey service. And this is one of the things that we're expert at, is building large-scale Elasticsearch systems. I'll talk about what we do in a few minutes, but this is a very challenging stack to run at scale. Even when you're using managed services, you still often have to manage the internals. So with AWS, the wonderful Elasticsearch service they provide, you still have to manage the cluster. You still have to manage the sharding of data, how data gets distributed. And it's really complicated. It's not something for the faint of heart, and it's something that you have to really learn how to do well at scale. And then finally, tracing. This is the least mature, the newest area. Many of the common projects out there, the most popular ones are Zipkin, Skywalking, and Jaeger. Us ourselves, we use Jaeger. We used to actually use Zipkin internally, but we have a managed service that actually offers Jaeger, which I'll talk about in a few minutes. Most of these systems, whether it's Jaeger or Zipkin that you're running, you also still have to run Kafka in order to distribute the data. You have to run Elasticsearch in order to scale the storage. So it's the same, similar types of problems. And on both Jaeger and Zipkin, you actually also have to run Spark, which builds these dependency views, these cool maps that you see within the products. And so it requires a lot of moving parts, a lot of components. Once again, pretty hard to run these things at scale. And I'll talk a little bit more about Jaeger as well, which came out of Uber. So it's a great open source project that's part of CNCF. And so we asked, as part of our, actually this is from 451 research, we asked what open source tools DevOps teams are using. And not surprisingly, Prometheus, very popular. It's relatively new in terms of the industry, but it's gotten widespread adoption. Whenever people are running Kubernetes, almost always they're running some type of Prometheus to capture metrics. So that's number one. Elastic Stack, or the ELK stack, is number two. It's been around for a long time, and so on and so forth. So you can see that these are all very popular projects. And you'll notice that the tracing tools are much further down the list because they're more complicated to implement, to get that tracing out of your applications. It can be quite difficult for sure. So, many of you are using some of these wonderful commercial tools out there. Probably the two big ones in the industry for quite some time, Splunk and Datadog. They both amassed a really big following. 30,000 companies buy products from both of them. I've been a Splunk customer many times. Fantastic product. Nothing wrong with these companies. But when you look at the amount of people using open source, there's almost 2 million companies that are using these open source technologies. And so you're talking about a very small number of companies that are using commercial tools versus open source. So by and large, when we talk to a company, although many of them do use these other commercial tools that are on the market, and many of them are great, by and large, most of them are looking to solve an open source problem. We have this complicated ELK stack. We don't know how to manage it. We're looking for help. We're looking for a service to do that. And that's really, by and large, what we see. And the same thing that many of the competition sees is open source is a big challenge for folks trying to scale this stuff. So very popular tools. So I did also want to share that open source is ubiquitous everywhere. A lot of people say, well, at big companies, they buy these observability tools, they don't build them, or they don't use open source. And you can see almost everyone that responded, or over 80% of the people that responded to our survey, the DevOps Pulse survey, said that they're using some kind of open source. So it almost always exists somewhere. It could be in a development environment. It could be a small team that's using these things. But it's ubiquitous. Open source is everywhere when it comes to observability. So the three options that you have as an organization that needs to run things in production or get visibility into what's happening in your environment is you can either build and run your own, which obviously takes expertise. You're going to have to take some of your engineers who are building other solutions and have them work on keeping the open source up and running, upgrading it, maintaining it. The second option is you can go and buy a tool from a company, one of these great companies that builds observability tools. There are many of them out there. But we believe that we fit a perfect balance between the two, where we offer open source tools that look and feel and act exactly the same as what you're already using in the open source observability space, but we provide a managed service and we provide added capabilities that I'll talk about in a moment. And people really pick open source because it's easy to integrate. As I said, a lot of these technologies are already built into Kubernetes. They're already built into the various frameworks and languages that you're using. And it makes it so that you don't have as high of a cost because the software itself is free. The services and the service that we offer at Logz.io is far more cost effective. And so what we do is we take ELK, we take open source Grafana, and we take Jaeger, and we bring it together into an easy-to-use unified platform that scales automatically, and we provide a bunch of capabilities on top of this platform. So if your team is already used to ELK or they're used to using open source Grafana, the transition is seamless. It's the same exact dashboards, the same views, the same capabilities, but we have additional value on top of them. So our platform allows you to ingest data from anywhere. We support almost every cloud provider, every technology from traditional data centers to the newest, latest, and greatest cloud technologies. We bring this into our unified data store that's based on Elasticsearch. We use a lot of Kafka, and we use other technologies as well to provide the service. You don't have to worry about that. That's what Logz.io does. You just use the service and enjoy what we provide. So we built a bunch of additional capabilities to correlate data together to ingest this data at scale and pare it down significantly. We then are able to apply some of our AI and machine learning capabilities on top, which I'll show in a brief demo in a couple of moments. And then we provide a log analytics product. We provide a cloud SIEM for those of you looking for better security visibility. And we provide infrastructure monitoring. And then finally, our newest product is our distributed tracing offering. And that's really what we do as a company, is we provide this scalable platform. Not only that, but we run across multiple regions and multiple clouds so that you can have the data where you want it on the cloud that you prefer it to run on. And then, of course, we also provide you with amazing customer service and customer support. You can look us up on G2 Crowd. We get some of the best ratings for our service and support. We're always ready to go above and beyond to build things for customers, to help them with dashboards and views and other challenges that they may have. We then provide role-based access control. We have all the security and the compliance requirements that enterprises and all companies require us to have. And it's about providing the scale. We make it so that it just scales and you don't have to deal with it. That's what we do. So really quick demo, I'm going to show you a couple of things in the product and just talk through it. So in the product here, this is Kibana, what we're looking at right now. And I'm just showing you that this acts exactly the same as the Kibana that you're used to and that you're running on your own. We can look at the log types. We can look at the various messages that are coming in. We also roll up the information. So instead of looking at the data just in raw logs, we bring forward patterns and exceptions within the data. Makes it easier to troubleshoot and pinpoint issues. Moving over to metrics here, this is open source Grafana. We provide all kinds of out-of-the-box dashboards and views. I'm going to take a look at a Kubernetes cluster here. We can then drill down by the pod, by the container type, by the image, all different types of ways that we can analyze and slice and dice this data. We provide all the out-of-the-box capabilities, the alerting, the features and functions that you know. Moving on to Jaeger, our newest product. This is exactly like open source Jaeger. We provide the ability to drill into the traces, to analyze exactly where the time is going, do comparative analysis. We also have the topology views and the other things that you would expect. You can drill all the way down into the code level, understand what's happening in your databases, your message queues, your caches. And it's all the things that you would get on your own if you were running Jaeger. I'll talk a little bit about the correlation in a moment, but let's just touch on a couple of the other features that we add on top. Something you don't get in open source is live tail, showing you real-time data. We also provide a really easy way for you to send us information. We support all the standard open source data collection methods. We even break out all the AWS data collection that we do and all the infrastructure monitoring and system metrics that we can collect as well. So we make it really easy with instructions and guides to do all of this. We have unified alerting. It shows you all the alerts that are happening within the system. And then finally, our insights. This is our AI and machine learning, where we take all of your log data and we actually surface interesting data that we're seeing. But not only do we look at exceptions like the one you just saw, but we also show you when we're seeing things that are being discussed in the community that indicate a problem. So we'll link over to Stack Overflow, how you can correct these issues, for example. And then finally, we have the operations tools and the security tools. You can switch back and forth between them, and that's a super quick demo of what the tool does and how it works. And I'll do another really quick demo showing some of the correlation and the things that are unique to our platform. So as we step through this one, I'm going to show you some of the linkages. So now we're back in Kibana. Just going to kind of show you the basic view here. And if we switch over to metrics from Kibana, because I'm looking to troubleshoot a problem, I want to jump into my Kubernetes cluster. I'm seeing some behavior that shows that there's an issue. And when I take a look at what's happening within the cluster, there's one of my containers is using a whole lot of CPU. I want to drill into that and see what's going on. I then can zoom in directly into this particular problem, and I see there's something going on. I want to then drill into the logs for that particular container. I just click on that one little button, and now I can see the logs here. So we've run out of file descriptors in this case. That's the problem showing up in the logs, which is likely the indicator. So we can drill in, we can see exactly what pod, what container is causing this issue. So it makes it really easy to correct that. Similarly, in Jaeger, we can also take a look at an individual trace. And as we drill into this individual trace that's showing poor performance, we can expand this and easily go to the logs related to the trace. In fact, all the data inside Jaeger is viewable in Kibana because it's all an Elasticsearch. So we can link between these two different technologies. It makes it really easy to troubleshoot problems. Finally, before I wrap up, I did want to talk about an exciting open source project that Amazon and many others have talked about recently. OpenTelemetry is a collection framework that's being built that basically is going to make it easy to collect logs, metrics, and traces from lots of different places and send it to your tool of choice or your tools of choice. And OpenTelemetry is currently in beta. It's about to be generally available, and it should be open to be consumed by the public very soon, and logging is going to be added into the standard next year. This makes it really easy to collect the information from the application layer, from your logs, from your metrics and traces, send them into a collector that can then send it off to the tool of your choice. So we're really looking forward to this project. We've been contributing to it. Logz.io already supports the tracing and the metrics, and we're part of the standard OpenTelemetry collector. So the industry's, happy about, the users are happy about the fact that they can then change tools and swap tools out really easily. Agents become commoditized. Everyone's going to be using the same data collection. So companies like us can focus on better machine learning, better AI, which is going to be great for innovation and great for the industry. So this is something to keep an eye on. AWS has their own distribution of OpenTelemetry, and we're looking forward to more and more innovation based on this great project that's part of the CNCF. So that was all I had to share with you today, and I hope you pop by our booth, come and say hi. I'll be there to discuss anything that you would like, and the rest of our team would be happy to show you what we do and how we work with AWS and your applications. And thank you very much for your time.